Welcome to the last lesson in this chapter, where I want to wrap up our discussion about application security by introducing you to encryption. We are going to use encryption to extend our current implementation of persisting the personal access tokens for GitHub access inside of the DevHabit system to be encrypted values inside of the database that we will decrypt when we need to call the GitHub API. This will significantly improve the security of our system and make it less of a problem if we run into a security breach. So let's jump into the code and let me show you what we are going to build. Currently, the GitHub Access Token service is responsible for persisting the personal access tokens inside of our application. So this is a perfect place where we can introduce encryption to make sure that the access token values that we are storing are always encrypted. We're also going to extend the getAsync method to decrypt the access token before returning it from this method. So let me show you what we will need to build this. First, I'll add an additional type in the settings folder that's going to represent my encryption options. So let me create the encryption options class. I'll make it public and sealed, and all I need is one property here that's going to be required, and it will be a string value, and this will be my encryption key. You can think of this as the master key that I will use to encrypt all of the access tokens. This could also be problematic from a security endpoint, because if someone gets access to my private key that I'm using for encryption, then they are able to decrypt all of the encrypted values. So it's a best practice to implement key rotation, but this is something that falls outside the scope of this course, so I'm going to leave some resources about that under this video. Now, how am I going to provide the encryption key? I can specify it inside of my application settings. For example, I can create a section called encryption and then pass in the key value directly from the application settings. But this also runs into the problem of storing sensitive data inside of source control. So I don't recommend using this approach. However, there are some constraints that we need to follow for the security key. For encryption, the security key should be exactly 32 bytes long. But this isn't the value that I will be using for encryption. Instead, I'm going to provide it inside of my user secrets, and right below this, I can add my encryption section, and I can specify the key value. And here's a random string representing my encryption key. It's base 64 encoded, and when you decode it back and turn it into an array of bytes, you get 32 bytes. So now I can close this down, and we will register this with dependency injection. So let's go to the add application services method, and I will say builder services configure, specify the encryption options, and provide the respective section where you can bind the values to the strongly typed options object. This will also respect my user secrets, which are going to take precedence, and at runtime the value from the user secrets will be set in this object. Now the next thing we need is something to implement encryption. So let's create a new service in the services folder, and I'm just going to call this the encryption service. Let's make this a sealed class, and we're going to inject an iOptions instance and specify the encryption options. What I want to do here is assign this to a private read-only field, which is an array of bytes, and I want to call it the master key. And I'm going to get this value by saying convert from base 64 string and specify the options value and then access the key property. And then we just need to expose two methods on this service. One is going to be the encrypt method, accepting in the plain text that we want to encrypt. And the other method that we need is the decrypt method, which is going to return a string. Let's call it decrypt, and this will accept the ciphertext and is going to return back the encrypted plain text. Now, how do we actually implement this? I'll create another constant that's going to represent the IV size. IV is short for initialization vector, and it's a component that adds a bit of randomness to our encryption process. So what do we need to do to implement this? Well, inside of .NET, there are already excellent solutions like the AES algorithm, Advanced Encryption Standard, and you can access it from the System Security Cryptography namespace. By calling AES create, you will get back an instance that you can use for encryption. And what I want to do here is assign a couple of properties. We already have our master key, and I also want to assign the initialization vector. Now here I want to use the random number generator to generate a random array of 16 bytes as the IV value, and this is something that should be unique for each encryption run. Now, typically, you also want to make the key unique, but then you have to somehow store the key value and the initialization vector to be able to decrypt this. So by storing the master key inside of our settings, and in production, we probably want to pull this value from some secure storage, we'll be able to implement a decently secure encryption approach. Now, I will have to store the IV value together with my encrypted data so that I can later decrypt it. I'll also set the mode for the encryption process to be cipher mode CBC. CBC is short for cipher blockchaining, and you can read more about this if you want to learn how encryption works. Now, I'm also going to explicitly set the padding. Even though these are the default values, I just want to make sure that I'm explicitly setting them, and I will do the same when performing decryption. So this is our base setup. Now we need to work a bit with streams. So let me create my memory stream that will hold the data that we are encrypting. So the first thing I'll do is write an array to this string, and I'm going to write the IV value that I randomly generated. The offset is 0, and the number of bytes to write is 16, represented by our constant. Then I'm going to create my encryptor using the AES instance that I have, and I can call the createEncryptor method. Now make sure that you are doing this inside of a using statement so that this is properly disposed of when you are done working with the encryptor. Then I will need a crypto stream. I can initialize this by providing the memory stream, the encryptor, and setting the crypto stream mode to write. And finally, one more component I need is a stream writer. Let's go ahead and initialize this as well. And here I will pass in the crypto stream as the argument to the stream writer. Finally, I can say stream writer write and pass in the plain text value that I want to encrypt. And now I can finally return my result, and I'm going to return it as a base 64 string, and I will say memory stream to array, and the memory stream will actually contain the bytes representing the initialization vector, the IV value, and the plain text which is encrypted using AES. Now this entire operation could fail, so I recommend wrapping it in a try-catch block, and the exception you want to catch is the cryptographic exception, and I won't be doing anything special here. I just want to be notified when this happens, and let's write a message saying encryption failed and just pass in the cryptographic exception as the inner exception. Now how about the decrypt method? Well, I'm going to paste in the implementation, and then let me walk you through the individual steps. Here we are simply doing the reverse of what we were doing in the encrypt method. So I'm first base 64 decoding my ciphertext to get back an array which contains my initialization vector and the encrypted value. The IV is an array of 16 bytes, and then anything that is left over represents our encrypted data. I can copy these values from the cipher data array into my two arrays representing the IV and the encrypted data. Then I'm going to initialize a new AES instance, set the cipher mode, set the padding mode, the master key, the IV value that we got from the ciphertext, and then I just need to create a memory stream from the encrypted data, create a decryptor, use this to create a crypto stream, and then pass that as the argument to a stream reader, which is going to allow me to read the value inside of this stream and return it as a string. So this will turn our ciphertext into the plain text that was actually decrypted. So that's it for encryption and decryption. Now let's register this as a service. I will say builder services at transient, specify the encryption service, and I can use it from the GitHub access token service. Let me inject it as another argument in the primary constructor. And what I want to do is to encrypt the access token using the encryption service, and then use that as the token value that I will be persisting in the database. So I'm going to update it here, but I also have to make a respective update in the getAsync method, where I will return null if the GitHub access token is null, and otherwise we can return the decrypted token. Now let's go ahead and start the application and test out if our encryption is working as expected. I'll send a PUT request to persist the personal access token, and this time it will be stored as an encrypted value. So let's send the request, and I land on the breakpoint in the GitHub access token service. So here we're going to extract an existing access token that now contains the unencrypted access token value. And we're going to go into the encryption service, where I'm going to create my new AES instance, configure all of the required values before creating the encryptor, and finally encrypting our plain text to get back an encrypted token. So you can see that this looks like some gibberish, and you can't really guess that this is an access token. So we are adding a layer of protection to our implementation for storing personal access tokens. Let me press continue, and I'm going to get back the response in Postman. And now I want to send a request to get the user's profile. So let me send this request. And we'll hit the breakpoint in the GitHub Access Token service. And this time I want to show you the decryption process. So if we go into the decrypt method, you can see how we are starting from the ciphertext, which is significantly longer than the access token was. So we extract the IV value and the encrypted data. And finally, we decrypt the encrypted text to get back the plain text, which represents our GitHub Access token that we can use to authenticate with the GitHub API. And if I press continue, you can see that this is working because we are getting back the response from the GitHub REST API. I hope you enjoyed this quick demonstration of how you can implement encryption in .NET using the Advanced Encryption Standard algorithm. With this lesson, we are going to wrap up this chapter about authentication and authorization in REST APIs. And we are ready to move on to our next chapter, where I'm going to demonstrate how we will integrate a client application that has a user interface with our REST API.